Here we are about to learn hybrid model and edge transistor. Let me first introduce you to what a hybrid model is. Hybrid model is an equivalent model of transistors used in small signal analysis. Hybrid model was widely used before the popularity of RE model. Now, in hybrid model, the parameters are defined in general terms of any operating condition, but in RE model, the parameters were defined in actual terms. That is why RE model later became very famous than hybrid model. Now we must understand what these parameters are. The parameters are called edge parameters because of the word hybrid, edge parameters. To understand the hybrid model, we must first know what is edge parameters and its significance. To understand the significance of edge parameters and to determine edge parameter, let us first study the two-port network and its terminal behavior. Now, two-port network, as you can see in the image, has two ports, port 1 and port 2, with current I1 and I2 and with potential difference V1 and V2 across each ports. We are to determine the parameter using these quantities that is given to us, I1 and I2, V1 and V2. And we are interested only in the terminal behavior of this port device and not in the interior behavior. Now we can say I1 and I2 are total currents and V1 and V2 as total voltages. We have four different quantities. Now we can determine the parameter using these four quantities by considering any of the two quantity as dependent and any of the two quantity as independent. In this case, I1 and V2 is independent, whereas I2 and V1 is dependent. Now, using this, we can write, as we have I2 as dependent variable, I2 equals function of I1 and V2, because I1 and V2 are independent variable or independent quantities, whereas I2 is dependent. Similarly, we considered V1 to be dependent, so we can write V1 as function of I1 and V2. And let us write this equation as equation 1 and equation 2. Writing equation 1 and 2 in total derivatives, del V1 equals del V1 by del I1 dot del I1 plus dV1 by del V2 dot del V2. And from equation 1 we can write di2 del I2 by del I1 dot del I1 plus del of I2 by del of V2. Now if we see, now this has V1 by I1, and we know that V by I is impedance. V by I is impedance, so this has the parameter this is a parameter having impedance. We can write this as H 1 and 1 because we have V1 and I1, and this has parameter of This is parameter H11 having impedance. And we can write this as H12. And if we see V1 by V2, it gets cancelled out in units. So this is a dimensionless parameter. And this is also dimensionless parameter because current and current gets cancelled out in unit. But as we can see, I2 by I1 gives us forward current gain. Forward current gain. H21. And we can write this as H22. We have written and we know that V by I is impedance, but I by V is impedance, admittance. So we have four parameters. Parameter 1 having impedance, parameter 2 having, let us talk about parameter 2, H12. If I2 by I1 gives us forward current gain, then V1 by V2 is giving us reverse current gain. Reverse voltage gain. Now we have four parameters, H11, H12, H21 and H22. V1 equals H11 I1 plus H12 V2. Similarly, I2 equals H21 I1 plus H22 V2. Writing this as equation 3 and equation 4. We have four parameters here, and these parameters are called hybrid parameters. And we can see and we can determine each parameter individually by considering any of the quantity to be 0. Let us first consider, to determine H11, consider V2 as 0. Let V2 be 0 from equation 3. V1 equals H11 I1 plus 0. H11 equals V1 by I1 when V2 is equal to 0. And from equation 4, I2 equals to H21 I1 plus 0. H21 equals I2 by I1 when V2 equals 0. Impedance, input impedance, I2 by I1 forward current gain. when V2 is 0. Now similarly, from equation 3 and 4, first we considered quantity V to be V2 to be 0 to determine H11 and H21. Now from equation 3 and 4 we are considering I1 quantity to be 0 in order to determine H12 and H22, which are the parameters of hybrid model. We have equation 3 and 4 as H11 plus I1 to V2. This was equation 3, and I2 equals to H21 plus H21 I1 plus H22 V2. This was equation 4. Now we are considering I2 to be 0 in equation 3 and 4. Hence we get V1 equals to 0 plus H12 V2 from equation 3. V1 equals to H12 V2. H12 equals V1 by V2 when I1 equals to 0, and we know V1 by V2 is reverse voltage gain. And similarly from equation 4, we are considering again I1 to be 0. So from equation 4, I2 equals H22 V2. Now H22 equals I2 by V2 when I1 equals to 0, and I2 by V2 is admittance, output admittance. Now let us rewrite equation 3 and equation 4. Let us rewrite equation 3 and equation 4 because we have determined these parameters H11, H12 and H21 and H22. So writing equation 3 and 4 again with its significance, V1 will be equals to H11. We know H11 is input impedance, so we will just write H11 as H small letter I subscript I, which is input impedance, and I1 plus H12 gives us forward current gain. So we will write this as H subscript F V2. And rewriting equation 4, I2 to be H21 gives us reverse voltage gain, so we will denote this reverse voltage gain with the small letter R subscript, I1 plus, and H22 gives us output admittance, so we will signify this with small letter O subscript V2. Now let us come to the part. This equation 3 and 4 is applicable to all the transistor configuration. We have three different transistor configuration: common emitter, common base, and common collector configuration. We have three different transistor configuration as common emitter, common base, and common collector, and this equation number 3 and 4 is applicable in all the three transistor configuration. Now moving on to nomenclature. It is denoted by notation HL1 and HL2, where L1 informs us about the nature of parameter, whether it is input impedance or forward current gain or output admittance or reverse voltage gain, and L2 informs us about the configuration of transistor, whether it is common emitter or common base or common collector. For example, we have input impedance in common emitter configuration. It is denoted by H. L1 is input impedance, and we have denoted input impedance with small I, so small I subscript in the subscript, and L2 emitter is common emitter is the configuration, so we will signify this with small letter e in the subscript. For another example, this was for input impedance. For another example, if we had output admittance in common base configuration, then it would be denoted by H O subscript because of the output admittance. We know that L1 informs us about the nature of parameter, and the L2 informs us about transistor configuration. So we have transistor configuration as common base configuration, so L2 will be denoted as small letter b in the subscript. So this was about nomenclature, and moving on to next, we have equation 3 and 4 rewritten. So we came to know about the hybrid parameters, the 4 parameters. Now using these parameters, hybrid model equivalent circuit is drawn, and the circuit looks like this. So using this equation, this equivalent circuit is drawn here. So this was everything about hybrid model.